Hello students, and welcome again to Topic 3 of Alternative and Renewable Energy Sources. This topic we will be covering solar energy fundamentals. This topic's lectures is broken into 3 parts. In each part we will do an activity. The activity is recorded and you are to work the activity along with the recording. We have some more definitions to go through. The meridian is an imaginary arc on the surface of the Earth from the North Pole to the South Pole that connects all locations running along it. This gives us a picture with a particular meridian highlighted. It can be seen that the line connects the North and South Poles. Dayton, Ohio is at a longitude of about 84 degrees west. That would be the particular meridian that goes through Dayton. North Pole is divided into different time zones. This slide gives a meridian which defines each of those time zones. Again, Dayton is on the meridian of about 84 degrees west and is in the Eastern time zone, which is associated at 75 degrees west. It is important to understand the motion of the sun with respect to the day and the seasons of the year. Solar hour angle gives us the angular position of the sun in degrees with respect to south at different times of the day. The equation reads that the solar hour angle is equal to the solar time minus 12 hours multiplied by 15 degrees per hour. Where does the 15 degrees come from? The circumference of the Earth being divided into 360 degrees, and the fact that it takes 24 hours for the Earth to make one revolution means dividing 360 by 24 means the sun will travel 15 degrees around the circumference of the Earth in an hour. This gives us a pictorial of the solar hour angle. The sun's location east of south is indicated by a minus angle, and its location west of south is indicated by a plus sign. All the seasons change from winter to summer. As the seasons change from winter to summer, the Earth goes from facing away from the sun to facing to the sun. There is an angle that exists between what we call the equatorial plane and a line connecting the center of the Earth with the center of the sun. We refer to this angle as a solar declination. This angle is a function of the time of the year, which we indicate by the day of the year. We indicate the day of the year by the letter N. The formula is given here. If the particular day of the months are not readily remembered, we can simply use an average of 30.4 days per month to calculate N. Here's an image that gives us a pictorial of the solar declination. Solar time is defined by the position of the sun. There is a difference between solar time and clock time. Solar time happens when solar noon happens when the sun is directly overhead. A line connecting a point on the Earth and connecting the sun would point directly south at solar noon at that location. Solar time is shown here. Solar time is based on the apparent angular motion of the sun and the time of the year. The rotation of the Earth is not consistent. Sometimes it speeds up and sometimes it slows down. This is referred to as perturbations in the Earth's rotation. It is approximated by the equation of time. If you do a Google search, you will find more than one equation for the equation of time. This is because these equations of time are best fit equations that represent the Earth's rotation. Here's a graphical plot of the equation of time. On a particular day of the year, represented by N, the graph tells us how many minutes we need to add to or subtract from clock time in our calculations of solar time. Here's the first step required in a correction to obtain the solar time from clock time. We must first account for the difference in the actual meridian of the location and the meridian of the time zone. The meridians are given here in 15 degrees increments around the Earth, starting at the prime meridian. If you look closely, you can approximate the meridian going through Dayton, Ohio, is about 84 degrees west. We are given the steps to determine solar time from clock time. We take the standard clock time, add to it the difference between the meridian of the time zone and the meridian of the location, multiply by 4. We then have to account for the equation of time. We calculate the number of the day of the year, look at the graphical representation of the equation of time, and add or subtract the minutes as indicated. You see two equations of time. They are both rather complicated. Very acceptable results can be obtained from using the graphical representation. Let's do an example. Let's assume it's 11 a.m. clock time on February 3rd in Dayton, Ohio. We first must account for the difference between the meridian of the Eastern Time Zone and the meridian through Dayton. The Eastern Time Zone meridian is at 75 degrees west, and Dayton is at the meridian of 84 degrees west. If we take 75 minus 84 and multiply the difference times 4, we obtain minus 36 minutes. This means that with only considering the meridians, the solar time at Dayton would be 36 minutes earlier than clock time. This would give us 10:24 a.m. Now we must account for the equation of time. February 3rd is the 34th day of the year. Looking at the graphical representation of the equation of time, we estimate a minus 14 minutes on the 34th day of the year. We now subtract 14 minutes from 10:24 a.m. and arrive at a solar time of 10:10 a.m. There are other formulas and example calculations on the next 4 slides from which you can calculate solar altitude angle, solar azimuth angle, the solar declination angle, and the solar hour angle. These formulas and calculations are included to give a complete accounting of many possible calculations. If there are any questions, please post them on eLearn Help Discussion.